Yeah, so that's how you manually read the state without using a Borsch schema. Now, my challenge for you is to do this sort of a thing for this sort of account. This sort of account. Because if you manage to do that, then you actually understand what's happening here. If you want a solution for this, I actually did this in my Solana NFT burner. Where did I do that? In the utils? Yeah, here. The get collection mint from metadata. My challenge was to get the collection, so this in the optional collection field for a given account. That would be the solution. How I did it manually. I mean, you can implement this nicer than me because that was just my first time trying this out, manually decoding an account. It's not the cleanest, but it works. You can also try and decode this with Borsch. That's also a challenge, right? Even with using the Borsch library, decoding this is not trivial. And something like this, decoding a complex account like this, is stuff that you will need to do in your career as a Solana developer, right? Because you have the programs and they store it like that. And at some point you want to read the data of the accounts. See you next time for more quality content. Yeah. Maybe it was even too easy for me this time because I've done this so many times. And that's why I didn't get too excited finally having something work, because it just all worked. Maybe I should still do something that doesn't work. Should we do something that doesn't work? Yeah. You know what? I'm gonna try and deserialize this account with Borsch because I haven't done that. Challenge accepted. I'm gonna use a separate video for still doing this with Borsch. Okay. Yeah, you persuaded me. I want to do this with Borsch now because I want to see if I can actually make that work, because it's not gonna be trivial. We're done with this, but we're not done with this. So I want to make myself a metadata decoder. And for that, we need some metadata account. So we start with a public key from a Solana NFT. And ideally, we want to use one that is updated for a collection. And if you don't have one, I wish I had one of those, but I don't. They have a marketplace. Oh, this one looks nice. I just want the token address, and let's quickly check the metadata here, because this I know is one of the collections that is actually updated to have this collection field here. And that's essentially what we want to read then to make this whole thing interesting. So we're just gonna copy the address of this token, put it here, and then we need to get the metadata account. And this we know we can derive with those seeds. So that's a nice repetition of what we learned today. You know, that part where we do find program address with some seeds, just that this time we get the metadata PDA and the bump that we don't need by finding this thing with the seeds and the program ID. Now, what is the program ID? That's the metadata program, which we will surely find somewhere here. And if not here, then we find it in here. In the IDL, that's always a good place to find the program. Wow, that's a big IDL. Here. That's our program, the meta, and our seeds. That's again something with buffer. So the first seed, to have it here, metadata, we also see it here, the literal metadata. Then the second seed is the program ID. So that's program ID once again, so that they actually have the program ID in there twice. Don't ask me why, but they do. We get the bytes from the program ID. And then what else is there? The mint. So that's again a public key. So that's the token mint. This thing also 2 bytes. Then we have the 3 seeds. We put the seeds and the program ID into find program address, and we get the metadata PDA back. Cool. If we then have a connection, this time we need to go to mainnet though. With the connection, we can say, and I'm gonna make myself a main again, so I can gonna do this whole thing in a main function. In fact, we can do everything here in a main function. Makes it a bit nicer actually, maybe. So having a connection now we can say get account info for this specific account. And that will give us a promise of an account info. That's just a buffer. We don't get the public key and buffer as we did with get program accounts, because there are several. Here we just get for one account the data, much more efficient. Const account info is this, if we await it. Then we can now, from this account info, get the data again, and this is the buffer. Yeah, I mean, we can do something like if we actually got an account info, if that account actually exists, because it might not, but in this case it does. Then we can get the actual buffer on the account info.data, right? And that's what we now use to decode some stuff, right? And for that we need to define our Borsch schema. How do you write schema? Borsch metadata layout. So we don't need to spell schema. Borsch dot import this. Then we can say struct. Perfect. This thing consists of first a key. So which type of metadata it is. Wait, how do you do that again? Borsch dot what it is. Okay. Dot, that's a U8, just 1 byte. The key. Then it has an update authority, which is a public key. Then it has a mint. Then it has a string name. That's how far I want to go for now and see if that actually works. If I then do key update authority mint name metadata, let's just put it all in one and say Borsch metadata layout decode this account info data. And then I just print the entire thing. Let's see. I'm actually interested if that actually works. Let's see if that works. Yes. 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 Whatever. So, I mean, it doesn't print it nicely, but we can see that it's a version 4. We have an update authority and we have the mint. We don't see it nicely, but I could be like metadata mint to base 58. If I were to put that out, we should get the same thing as we have here. Perfect. That works. Okay, so far so good. Now, what do we see here though? If we read the string, the name, and we decode it with Borsch, it reads this with a bunch of 0 characters. So the filling is still in there. It still doesn't trim this. So apparently on chain, it says that the length of the string is in fact 32, even if it's like shorter, which actually makes it easier for us to decode this with Borsch, because we can now just add the next thing. Because if the length still is 32, then I'm fine, right? So then if you read the name, you just need to treat it as a C string where the first 0 character is the end of the string. But anyway, moving on with this, we can just continue decoding, because we then have another string for the symbol. Then we have another string for the URI. Then we have 2 bytes for the seller fee basis points. So that is a U16 seller fee basis points. Complicated name, I know. And then it starts to get complicated. But let's see if we can get this far and see if we can get the seller fee basis points. Yep, 600, which means 6%, which corresponds to what we have here and also what we see here. Yeah, okay, I mean, that's still easy enough. But again, we see that they store it like with the zeros in there. Then we have creators. Okay, so now it's getting a bit more complicated because this is optional. We have an optional array of creators. And I think it's more of a vector than an array, but I'm not actually sure. So I've never done arrays with Borsch. Time to find out how this is done. Wait, no, first it needs an option of another Borsch layout, which has address, which is a public key, and it has verified, which is a boolean, and it has share, which is 1 byte. U8 share. So that's the struct, and that whole thing is called creators. Let's see if that works. Can I get the creators? No. Invalid bool. Ha. Okay, so something is not correctly aligned with our decoding. That's why we get a decoding error. We try to decode 219 as a boolean because in fact, yeah, that's right. It's not just an option, but it's an optional array, which I think still is a vector, not an array, because we can have up to 5, but I still think it is encoded as a vector. Let's see. We have an option of vector of a struct. Just gonna call this array, which is a vector, which is stupid, but whatever. Now close that. And then I still have the option, and I call the option creators. Does that now look good? Kinda, but also not really. Maybe I do it like this. Does it now look better? Never mind, it doesn't need to look good, it just needs to be, just need to work. But let's see if it works. If I were to get the creators, oh, it went through. Creators, I have one element with an address, which is a public key, verified true, share 100. That sounds good because that's also what we saw on here. There's just one creator and the first element. Oh, so it is an array. Wait, no, 3 items. Yeah. One element in the creators has 100% share. Okay. So if I were to put creators, first one of the creators, can I do that? Dot address dot to base 58. That should then return me the 9UB, and voila, we have the 9UB. Cool, that works. Does it also work with array? No, because then I need to give the fixed length, and I don't know the fixed length. So I'm pretty sure that what you have here is a vector. Anyway, moving on, we have the creators. Next thing is the primary sale happened, which is just one boolean. Bool. Primary sale happened. Then we have is mutable. Then we have an addition nonce, which is optional and is a 2-byte what number? So is first of all a Borsch option of a Borsch struct with a Borsch U16 that we call addition nonce. Just for fun, see if we're still on track. Damn it, we're not on track. Fields must be array of layout instances. Oh, I don't know. Yeah, so we have the... What if I don't put a value in here though? Because I don't want to have this an object. Oh, then it's just empty? Damn. Well, I'm just gonna keep it like that then. It's ugly, but it works. Again, same thing with the token standard. Again, I don't know how to do this properly, but it will do. And then the collection is optional, and it's just one thing that has subfields though. So it's another Borsch option with the following struct, and that's called collection. And in the struct we have a boolean and the key, boolean verified, public key, key. That's the collection. Let's see if we can get out the collection. I don't. Collection dot key dot to base 58. Nope. What did I do now? Oh, that ends the struct. Ah, I'm missing a bracket. Okay. There we go. Now that was a lot easier with Borsch than how I did it complicatedly, like this manually with slicing the buffer around and keeping an offset. Much easier to just define the layout and then decode. So yeah, Borsch is really helpful. You just need to know how you use it. And yeah, that's how you get the collection. And for completeness, let's also do the uses and the collection details. Don't think they have that, but if they had, and that's to check that the option works. So we have optional uses, so another optional struct uses with a use method remaining and total u8 8 bytes. 8 bytes, that's a lot, because what is 8 times 8? 64. Okay, it's not so bad. We still have that. That's uses now remaining, and the same for total. Yeah, I don't want to deal with the enum, I just use a u8. And then we have an optional collection details, which is also an enum, but this should not be present here anyway. So let's see what happens if I decode this. Cool, it works. And all of our data now, we see that the token standard is not set, uses are not set, and collection details are also not set. But we have the update authority, the mint, the names, RFV basis points, the creators, or the one creator is here. And now this should work for any token. For instance, if I were to put in, if I use this guy, public key in here, and I decode it. Oh no, invalid option collection. Oh, because we might not have the same standard. It might still be on an old account model because they are really old and they are immutable and can't be updated. They're not mutable anymore, and they don't support the collection yet as an option. Yeah. So point is, with Borsch, it is quite a bit easier than to do this manually, but it's also really helpful to do it manually at least once, such that you know how you can define those options, right? What that means, that you need to read one byte, and if that byte is set, then read the entire thing, otherwise skip. And with the vectors as well, that you need to read the amount first, and yeah, with a string, read the length, the 4 bytes, the 4 bytes. So yeah, we've done it once with Borsch, and you can also check out how I did it manually. But now I definitely want to end it. We definitely did more than we needed to do for the deserialization of custom account data. And as I said, I will see you in the next video, because now I definitely need a break. I'll see you in the next one. Peace. And check out those videos, and then I'll see you in the next, and like and subscribe and follow me on Twitter and swipe right on Tinder, and yeah, see you around.